This is the cylinders practice. Okay, so it looks like this on the top. It says worksheet 8.2. It doesn't say cylinders, but it's worksheet 8.2 is the cylinders practice. So we got to find the surface area and volume of these cylinders. Cylinders are comprised of two bases that are circles. So you got to think of a can of tuna, a can of peas, a can of vegetables, a can of pumpkin, whatever it's going to be. And you have a top and a bottom. So the top and the bottom are circles. So to find the area of a circle, we have pi r squared. Pi r squared. So the area of the circle down here is going to be pi times the radius, which is 4 squared. So that's going to be 16 pi. So it's 50.3. Approximately 50.3, and that's going to be meters squared. Okay, there are two bases. So 50.3 meters squared, and at the top there we have another 50.3 meters squared. So 50.3 plus 50.3 is going to give us 100.6. Meters squared. Okay, then we got to find the lateral area. So again, on our can, we want to think of the label. If we take the label off the can, it's going to form a rectangle. So if we take this off, we uncylinderize it. We whatever the word would be there, and we unravel it. Okay, the length here of the rectangle is going to be 2 pi r. It's going to be the length around. Okay, and then we're going to have our height. So our area formula for the lateral area is going to be 2 pi r h. Length times width, 2 pi r times h. So that's 2 pi times 4 times the height, which is 9. That's going to give us 72 pi. Which is approximately 226.2. And again, our units there are meters squared. So 226.2 meters squared. So our total area is just simply 100.6 plus 226.2, which is 326.8 meters squared. Okay, so we get the total surface. Again, this says total area, also means surface area. So the surface area, again, is you have 50.3 is the area of the bottom of the can, or the bottom of the cylinder. 50.3 is the area of the top of the cylinder. And then 226.2 is the area around the cylinder. So you add those three numbers together, 50.3 plus 50.3 plus 226 to get the total surface area. Okay, and then volume, just like a prism, was the base area times the height. In this case, the base area was pi r squared times h. So pi times 4 squared times the height, which is 9. Again, you got to think of filling a swimming pool. If you have a circular swimming pool, okay, it's going to look like a cylinder. Okay, think of an infinitely thin layer at the bottom, covering the area of the entire bottom of the pool. You need to take that area and multiply by how high the pool is to see how much water it can fill it up. Okay, so that's going to be 4 squared 16. 16 times 9 is 144, so you get 144 times pi. That's the best answer. If you put 144 pi meters cubed, that would be the perfect answer. But we're going to approximate by making it just one decimal. So 144, 4 squared, you can just put that in your calculator. Okay, it should be the same as 144 pi, which is 452.4. Approximately 452.4, and the units are meters cubed. meters cubed because it's three-dimensional. Volume is three-dimensional. You have uh, 3 dimensions, right? You have 4 meters times 4 meters is 16 meters squared. 16 meters squared times 9 meters is 144 meters cubed. Then 144 meters cubed times pi is 452.4 meters cubed. 2 and 3 are just like this one. There's both cylinders. The difference here is we have giving a diameter, so we know our radius is going to be 10. So the area of the bottom circle, pi r squared, is going to be pi times 10 squared. That's 100 pi, which is 314. Approximately 314.15, so that's 0.2, say 314.2. Centimeters squared. Okay, there are 2 bases, 2 circles. So if you want to cover both those circles with wrapping paper, we're going to need 314.2 plus 314.2, which is going to give us 628.4 centimeters squared. It's a little bit off, but that should be centimeters squared. Centimeters squared. Lateral area, the area around the cylinder, so we find that by 2 pi rh. So the distance around the cylinder times the height of the cylinder. So again, that's going to be 2 pi times 10 times the height of 7. That's going to be 140 pi. So 439.8 centimeters squared. So that's our lateral area. Which means our total area is the lateral area, the area around the cylinder, plus the area of the 2 circles. Each were 314. Together they were 628. So 628.4 plus 439.8 is 1068.2. Again, centimeters squared. Okay, and finally, our volume, again, is the base area, which is pi r squared times the height. So the base is a circle, so we got to find the area of the base. So again, think of swimming pool. We got to find the area of the base of the swimming pool. And that's pi times 10 squared. We need to take that area and we need to multiply by how high it is, so how much water it's going to fill up or is needed to fill it up. So we need to multiply by the height, which in this case is 7 centimeters. So that's going to be 700 pi. Okay. Which is 2,199.1 centimeters cubed. So 2,199.1 centimeters cubed. And it's volume, so it's cubed. It's 3-dimensional. Again, if you're finding surface area, that's like how much wrapping paper do you need to cover all of the cylinder, and wrapping paper is 2-dimensional. Whereas volume is how much space are you filling up? Like, for example, how much water do you need to fill a pool? And that's 3-dimensional. There's 3 dimensions to it. Third one. Okay, again, just a basic cylinder, so we're using the exact same process here. The base is a circle, so that's going to be pi r squared. Here, they're giving us a radius of 11. So that's going to be 121 pi. is going to be approximately 380.1 feet squared. Again, there's two circles. So the area of the top circle is 380.1. The area of the bottom circle is 380.1. So times 2 or add them together. That's 720.3 because I didn't round off on the other one. So it's 760.3 feet squared. Then we got to find the lateral area, the area around. So again, think of it as a label on a can. You take that label off, it's going to be a rectangle. So the area of that rectangle is going to be length times width. The length is the circumference around the cylinder, and the width is the height of the cylinder. So 2 pi times the radius, which is 4. Nope, it's 11. Radius is 11, and the height is 20. That is 220 times 2 is 440 pi. So we get approximately 1382. Oops, 1382.3 feet squared. Square feet. Okay, 1382. You add the area of the top circle, the bottom circle, the lateral area to get the total area. So that's 760.3 plus your lateral area there, and that gives you a total of 2,142.6 feet squared. So if you needed to wrap up the cylinder, you would need 2,142.6 feet of square feet of wrapping paper. Okay, and then volume. And pi r squared h. You guys should fly through these cylinder problems. Pi times 11 squared times the height of 20. 11 squared is 121. 121 times 20. 2,420. Let's just put in the calculator to double check. Where's square times 20. And then times pi. 7,000, approximately 7,602.7 feet cubed. So 7,602.7 feet cubed. Okay. Problem 4 is, I believe, a cylinder and a cube. Yeah, so they're asking find the volume of the space between the cube and the cylinder. Okay, so we got to find the volume of the cube and the volume of the cylinder, and subtract the volume of the cylinder from the volume of the cube to get the space in between the volume and the cylinder. So our volume for a cube, right, is the base area times the height. Okay, well, the base is a cube, so it's 4 by 4, and the height is also going to be 4. Again, it looks elongated on right because of the projector, but our base area is going to be 4 by 4 is 16. Right? The area of this base right here is length times width, so it's going to be 4 by 4, which means it's going to be 16. So our base area is 16, and then our height here is 4 because it's a cube. So all the sides are 4. So 16 times 4, which is going to give us 64 feet cubed. So the volume, the amount of water you could put in this cube would be 64 cubic feet of water. Okay, but it's like if now we insert a cylinder and that pushes all the water out, how much water is left? So imagine you had a little box and you put a can of Pepsi or something in there. Okay, and how much water would be left once you push out the volume of the can of Pepsi? How much? The volume of the can is how much is going to be displaced. We want to know how much is left. The volume of the cylinder, pi r squared h. So pi times, what's the radius? It's 4 feet across here, this length right here. Okay, this length right here is going to be 4. Okay, so that's the diameter. So we know the diameter is 4. So the radius is going to be 2. And the height, again, it's a cube. So the cylinder fills all the way up. So the height of the cylinder is also going to be 5. Okay, so our volume here is going to be 20 pi, which is about 62.8. Feet cubed. Okay. So most of the water is going to end up getting displaced here. Okay, so 64 is the volume of the cube, and we want to subtract away 62.8, which is going to leave us 1.2 feet cubed. 1.2 feet cubed. The volume of the sphere I'm just checking because it looks a little small to me, but we did everything right. 16, 4. Oh, no. Height is 4. That's why. I see you get a small number. You got, yeah, this is 4. Height is 4, not 5. I was thinking of the first cube. It's 5 by 5. This one's 4. So our height should be 4. So it should be 16 pi. Which is 50.3, right? And that one enough times, you know it by heart. 50.3 feet cubed. So this is 50.3 feet cubed. So 64 minus our answer there is going to give us 13.7. 13.7 feet cubed. That looks like a much better answer. Then 5 and 6 are a review of prisms. So here we have a rectangular prism. So our rectangle has 6 sides. We're going to call, it's called the top and the bottom of the base. Top and bottom here are the bases. So the bases are rectangles. So the area of a rectangle is length times width. So that's going to be 4 times 4, which is 16. And there are 2 of them. 16 centimeters squared. There are 2 of them. Okay, so that's going to give us the bases added together are 32. Then this particular rectangular prism is, since the bases are square, is going to have 4 rectangles for the sides that are all the same. Okay, so on the right, left, front, and back of this rectangular prism, they're all going to be rectangles that are 4 by 12. Here we'll have 4 by 12, 4 by 12, and 4 by 12. So we have 4.
Can you grab a chair for it?
Okay, so we have 4 rectangles that are 4 by 12. Okay, so area for a rectangle is length times width. So we have 4 by 12. Okay, so that's going to give us 48 centimeters squared. And again, there's 4 of them, so we want to do 48 times 8, 4. Or 48 plus 48 plus 48 plus 48. which is 192. So our lateral area is 192 centimeters squared. Okay, total area then we have 48, 48, 48, 48, 16, and 16. We need to add them all together, or we can add the 32 plus the 192. So we're going to get 224 centimeters squared. And the last step here is volume. So again, volume of a prism is the base area times the height. Our base area was 16. The area of the base here was 16 times the height, which was 12. 16 times 12. What's that? 144 plus 48, 196. 144, 192. Okay, and those units are centimeters cubed. Okay. Volume is 192 centimeters cubed. And the last one, number 6 here. Okay, it's a regular pentagon. So I told you guys the area for the pentagon. So again, our formula for the pentagon. It's not something you need to know, but it looks something like this. What was it? 1/4. I have it written down. 5 times 5 plus 2 root 5 times a squared. Okay, so 5. So it was, the a was a 5, so this became a 25. But anyways, we got about approximately 43. Okay, so we just went with it. So I told you guys the area here was 43. I think I didn't tell 5th hour, but I definitely remember telling 1st through 4th hour. So 5th hour might be a little confused and lost, but that's okay. So the area of one pentagon here is 43. We have 2 pentagons. I mean, they can Google this just like I Googled it, right? Okay, so the area of both those pentagons, each one is 43, so that's 43 plus 43, which is 86. And that is centimeters squared. Okay, lateral area. We have the pentagonal prism. So we have pentagons on this as their bases. So we have 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles, 5. Okay, so it's a little messy, but there's 5 rectangles there. Okay, so each rectangle is the area for each one, length times width. So each one's going to be 5 by 10. So each one is going to be 50 centimeters squared. And again, there's 5 of them. So you can do 50 plus 50 plus 50 plus 50 plus 50, or 50 times 5, which is 250. So 250 centimeters squared. That does not look like 250. 250. Okay, and the total area, 43 plus 33 plus 50 plus 50 plus 50 plus 50 plus 50, or 250 plus 86, which should be 336 centimeters squared. Then we go to volume. And volume is the base area times the height. Our base area we said was 43, and I gave it to you. 43, the area of the pentagon was 43. The height is 10. The distance between the 2 bases is 10. That's our height. So your volume is 430 centimeters cubed. Okay, and that's the cylinders worksheet with a couple prism review problems.